Yes, bins. Bins, bins, bins. You like my little dance?
Yeah. I was doing your computer dance. You ever saw it?
Dude, I was trying to steal my thunder.
It was very interesting. And I was like, don't I have to like write the like, don't I write something? Like I say, like, no?
Bins is it. No, you're good. You're golden. Naomi's gonna do B.
I didn't write it. I saw it in my bed. Everything kind of
I skipped in for time.
and ended up having like the opposite.
I'm sure it's like an all because I know that it's one so they probably just never get back.
Thank you, ma'am. Alright, so if you ever referenced your notes from previous class periods, not a bad idea, by the way. We did talk about the conditions for using normal approximation. Was on this page. N times p is greater than or equal to 10. N times 1 minus p is greater than or equal to 10. If those two things are met, that means that instead of having to use a binomial distribution, we can use a normal distribution. So our normal curve, which we're much more familiar with. Technically, NP, first of all, that's your mean. Remember, for a binomial variable, n times p is your mean. That was a really bad mu, sorry.
I thought it was okay.
It's also the number of successes.
Why'd you guys both look at me?
N times 1 minus p, that's nothing mean or standard deviation wise, but it's the number of failures.
Let's say 1 minus p.
Yeah, 1 minus p. The number of failures and the number of successes should add to n. So if we have 250 successes, we should be able to really quickly just know that we have 250 failures and not necessarily actually have to use the formula, because it should always add to what our sample size is. So since those two conditions are met, we can do part C using a normal curve. So we're going to draw that. The mean is n times p, or 250. You too. Get along.
He started it.
Standard deviation, remember, comes from the square root of n times p times 1 minus p. So n is 500, p is 0.5, so that means 1 minus p is also 0.5. So we have 500 times 0.5 times 0.5, which is 125, and then we're going to square root that. So our standard deviation is 11.18-ish.
11.18.
Then we're going to put all our hash marks on our normal curve. At the center is the mean, so 250. Then we're going to add the 11.18 multiple times 250 plus 11.18 plus 11.18 plus 11.18. So we have 261.18, 272.36, and 283.54. And then we're going to subtract the 11.18 for the other side. So we have 238.82. Maybe if I can keep my paper straight. And then we have 227.64 and 216.46. All right, what number are we interested in, Trey?
I can't see what that says.
It's on the paper in front of you.
I don't have it.
It's in the typed up stuff.
Oh, this stuff?
C. Part C. At the bottom.
235.
235. Thank you. We're interested in at least 235. So that's going to be here-ish. 235. Is it least, greater than, or less than? Greater than.
Greater than?
Great. Greater than. Thank you, Nashley. So it's a normal curve. So what's our calculator function? Put it back. Normal CDF. Thank you, Maggie.
You got the norm part right.
You did get the norm part right.
Not the butt.
All right, so lower bound is 235, upper bound, big number. Mean is 250, standard deviation is 11.18, and of course, I ran out of space with my big handwriting. Normal CDF, 235, big number, 250, 11.18. So we get 0.9102 when we round. So today is the last new stuff for this unit. We're going to learn about geometric variables. So far this unit we've talked about discrete variables, continuous variables, normal, binomial, and now we're going to do geometric. All right.
Hey.
Thank you.
We're all talking. It's not just me.
Yeah, I was waiting for you and Ty. That was it. All right, a geometric variable is the count of the number of trials needed to obtain the first success. So x can take the values 1, 2, 3, all the way up to x. X includes the trial that is the first success. So an example of a geometric variable would be the number of times Davis has to shoot a free throw until he makes it.
Were you at the game?
No, but oh my gosh, the Roseburg announcer, he was hilarious.
Was he so good?
He
Oh, I
was
thought about it.
the free throw shooters. He was like, I think it was Owen Scott was taking free throw. He's like, Owen Scott's a 38% free throw shooter, and he'd make it, and he'd be like, that's weird. That's against the odds. And it was like, Sky
what'd he
was
say when
like
I was
roasting you guys. It
What'd
was
he say when I was up?
hilarious. I don't remember.
They told me at the 8th grade game this year. Like I ran past this.
Get it because he's short?
Yes. Bro, where does that even come from? Smart.
All right. Another example would be something like the number of times you have to roll a dice until you get a. Somebody give me a number.
2.
2.
Where did 1 come from? Are you looking at the nutsack or the Virginia?
Just being called nutsack.
Oh, I've never heard of it in my life. Why are you calling it nutsack?
I don't know. Katie was calling it.
Or it could be the number of times we have to toss a coin until we get a tail. Of course it is.
Tails are universally known as the bad part of life.
No. I think this is something you've created in your head.
No. Heads are always the good one, and tails are the bad one.
No.
Yes.
I disagree.
Who here likes tails?
I do. Thanks, Alyssa.
And
I actually call tails like if
Yeah, you called tails.
More people call tails.
All right. So just like a binomial variable had an acronym, geometric variables have an acronym we need to check. We still have B for binary. Each observation falls into one of just 2 categories, which we call success and failure. Independent. The N observations are all independent, meaning knowing the outcome of one trial has no effect on the outcome of the next.
Dude, never let this kid sit in front of me. Screw your
bitch.
And then it switches. So for binomial, the next letter is N, but now we switch to T. T stands for the number of trials, and the goal is to count the number of trials until the first success. And then we have S, probability of success. P is the same for each trial. So for geometric, it's bits. For binomial, it's bins. Which one is the main difference? The N and the T. What did we change?
We know how many bins.
We know how many in bins. Bins means we have a fixed number of trials. Geometric means we're just going to go until the first success.
Kid. B. You're not even using it, bro.
Yeah, you people.
it's not. Stop saying it.
Only I get to pick on time.
Well,
All right, so now we're going to look at some geometric probabilities. Going to look at the formula, then of course I'll teach you how the calculator actually does it. May I move my paper up?
Yes, ma'am.
Thank you, Ashley. So, we're going to roll a number cube, also known as a regular six-sided die. We're going to let x represent the number of rolls until we get a 3. Is x a geometric variable?
yes.
Yes. B, it would be weird if it wasn't, but maybe I'll throw a trick in there sometime. B, success is a 3. A failure is anything not a 3.
Oh, yeah.
Rolling a die is independent, so knowing the outcome of one die roll has no effect on the other. Number of trials is not fixed because we're just going to go until we get a 3. What is the probability of success? What's the probability I get a 3? 1/6. So now we're going to find the probability that it takes us 1 roll to get a 3, 2 rolls, 3 rolls, and then n rolls.
Start.
I'm sorry. There. Now it's too bright. It'll focus. Maybe. There we go. All right, so what's the probability that I get a 3 on my first roll? 1/6. So x equals 1 means 3 on the first roll, and that's just 1 out of 6. What's the probability that it takes me 2 rolls to get a 3? I rolled the die once, and I don't get a 3, so I got a failure. And then on the next roll, I get my success. What's the probability that I get a failure, or I don't get a 3? 5 out of 6. There are 5 out of 6 ways I don't get a 3. And then I'm going to multiply that by 1/6 because they are independent, and we know that we can multiply independent probabilities. I don't know. 5 out of 36 is 0.138 repeating. 0.138. So what's the probability it takes me 3 rolls? Say it louder, Brooke.
5/6 is 5/6, 1/6.
Thank you, ma'am. We have a failure, then a success. So we're going to do 5/6 times 5/6 times 1/6, like Brooke said. Which would be something. That's 25 over 216.116 when I round. Gold star.
You actually have them?
Bless you. COVID.
I got orange. I was really bad star. All right, so what's the probability it's going to take me n rolls to get a 3?
Colton's working on his car code.
Just P? That's it? Like, nothing gonna be added to that?
Times n.
No, that's binomial. N times P is binomial. Thank you for trying though, Mason. What's the probability of failure? 5, 6. How many failures am I gonna have?
Let's have a look.
You need to react to Colin's be real because he's skipping. You ready?
No. 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 If it takes us, notice we had 3 rolls till we got a 3. So we had 2 failures and then our success. So if we have n rolls until we get a 3, that means we have n minus 1 failures. So we can raise our probability of failure to the n minus 1 power. And then we have our 1 success. So we're going to multiply by the probability of success there at the end. Now on, what did you say, Caleb? Okay. You don't want to share? Okay. We're going to generalize. This is what it would look like on the AP formula sheet. So X is a geometric distribution with probability P of success, 1 minus P of failure. And the first success occurs on the kth trial. Kth. Kth. It's K to the TH. Kth. Kth. This nth is an actual word. Like if you're playing Scrabble and you got no vowels, nth. That's a great word to use. Kth. How would you say it?
Yes! Went from a 33 to a 44.
Okay, kth.
Wait.
All right.
What am I at?
Notice. Quiet back down. Notice that we have our probability of failure, which we're going to use 1 minus P. Then we had the number of trials minus 1.
This is getting out of hand.
Oh, she did bring me a Slurpee. Look at that. Why, thank you.
Hey, I got a 20 out of 20 on my reading. That is surprising.
What's the reading?
Thank you, Dave.
Oh, the first one?
Yeah. Thank you.
But there's no seat by Mason for you.
You got a 20 out of 20?
There's no seat for you to sit by
8 out of 10.
Mason.
Or 8 out of 20. Well, yeah, 25
All right.
is what you can do, so yeah.
Davis. Trey.
Ma'am.
It's little.
What?
All right.
Megan, do you want the vocab?
Probability of failure. Tell her to be quiet.
Be quiet.
Thank
Do you
you.
want the vocab for the scarlet letter?
Clara. Thank you.
What?
That's what I'm trying to get back to, but it was too noisy. 1 minus P is the probability of failure. We are going to take K number of trials till we get our first success. So we fail K minus 1 times. So we take our probability of failure raised to the K minus 1 power. And then we have that 1 success, so we multiply by the probability of success, P.
What does K stand for?
The number of times it takes until we get our first success.
Don't actually solve it, we just leave it like
That's just the formula.
Oh.
If you see an AP formula sheet, that's what it looks like. Don't freak out.
So in the test, we just give an actual,
Yes. And I'm going to show you how to do it on the calculator now, instead of by hand. I'm going to flip. Trey Newman.
You give me gingerbread.
We're going to play a guessing game.
One.
Not that kind of guessing game, naturally. We're going to guess the mean.
It's C.
They just stole my pencil.
All right.
Don't.
If X represents the number of tosses of a coin needed, how many times do you think we have to toss a coin until we get a head?
Twice.
Who said twice?
Me. Ty.
Wow, good job, Ty. Candy.
Yeah. He's a dog. You get the treat, man.
Why did you say it twice?
Because there's only two sides. There's only two sides. There are two options you can get.
So what's the probability of success? 1/2.
I think you can
All right, we're gonna throw a die until we get a 2. How many times do we gotta throw a die until we get a 2?
2.
6?
Ah, she said
Trust
2.
yourself. Don't listen to Trey. 6. Why? Why?
Because
There's
that.
6 sides of the die.
There are 6 sides of the die.
So what happens if we?
What's the probability of success? 1 out of 6.
What happens if we roll the same
On
thing twice?
average. It should only take us 6 tries. But it could take us longer. Sure. You guys know I got die.
Let's test it.
That's not that bad.
Let's
Holy shit, she got a one.
She got a lot of that.
I do have a lot of die.
Alright, roll it.
Okay, we're looking for a 2.
Why
So
one?
that was 1,
Oh, 5.
2,
3, 4,
4,
5, 6,
You suck.
7,
You suck. You
8,
suck.
You're never gonna get a 2.
Do it.
9,
I'll
10,
You suck.
11,
You suck.
12,
So you
13,
got everything but 2.
14, 15,
Joke's
that's
on
a
you, there's no
1,
2 on it.
16, 17, 18, 19, I was at 3, 20, you need to learn how to roll on the paper, 21, 22, 23,
Okay, we get the point.
24, hey, 25, finally got it. All right, on average though, if we were to do a bunch of trials, it really should only take about 6 rolls before you get your first 2.
Well, we have to do 6 rolls like each. Like if we were to do it 5 times, we have to roll it 6 times. Each of those 5 times. So we roll it
Yeah, but
30
we're not
times
going
to
to
find
do
the
a
average.
simulation. Yes, but we're
That's
not.
how it would work.
We're not going to do a simulation. All right. Anybody happen to notice a relationship between our probability of success and our mean?
It's whatever it's out of.
It's whatever it's out of.
What was the question?
What's the relationship between your probability of success and your mean?
It's
The
the
denominator.
denominator.
It's the denominator.
Reciprocal.
Thank you.
Ah,
Reciprocals. That gets candy. Reciprocals.
did I still get a candy?
I threw you a candy.
I answered another question.
I lost one in there.
If Nashly gets candy, then
You
I
get
need
3.
candy.
Whoa! What?
Word reciprocals.
Hold on. I need half of one of those.
Did you not?
I need half of one. I got half of
Ow!
You're bad.
All right, so in general, if our probability of success is P, the reciprocal of P
Lick my shoe.
would be 1 divided by P, which that is our formula for finding the mean when we're working with geometric variables.
This is actually so easy.
The formula for standard deviation, not something I can make you guess. So just trust me. And actually, I can't make it fit there neatly, so I'm going to write it down below. It is the square root of 1 minus p divided by p squared.
Oh my.
And now we're gonna go back to the Starburst examples.
What?
And I'm going to show you the calculator function for geometric variables. This time, we're just going to pick Starburst from the bag until we get the first cherry. We're also going to assume that my bags were normal and had pink in them. Okay. Sorry. It just makes it easier. All right, so X represents the number of Starburst candies until the first cherry appears. Is that a geometric distribution?
Yes.
Yes, because like Mason said, it'd be weird for me to have a lesson on geometric variables if it wasn't one. Yes. Binary, success is a cherry, failure is not cherry. Independent, I pulled a high school student habit, and I didn't actually read because it does tell us to assume it is independent. So I'm just going to drop my highlighter cap and put quotations around the word independent. T, N is not fixed. We don't have a set number of trials. We're just going to go until that first cherry candy. There are 4 flavors in a normal bag. And S, probability of success. If my bag of Starburst had all 4 flavors, what would the probability of success be? 1 out of 4. So what is N? What's our sample size? What? Until. Until cherry. There is no sample size. It's not fixed. We're just going to keep going until cherry. Hi, JLK. What?
I go by.
And you only gave me half credit.
Well, yeah, you only had half of
But I
it.
got all of that and all the answers correctly.
That is some beautiful copy.
Thank you.
Yes. Thank you. I will update it.
Thank you.
All right, what is P?
No, it's not.
We already said it.
1/4.
1/4. So, the mean of X.
Good.
That's our new formula. I'm going to move my paper. The mean for geometric variables is 1 divided by P. So 1 divided by 1/4 is going to give us 4.
Really, the board?
How do we interpret our mean? What does the mean tell us? On average, how many pieces of candy we would expect to pick out of the bag until we get that first cherry. 4. And I'm sure you guys can say it better than me.
So can you read it a little bit?
Yes, I am sorry. Great catch, Megan. All right. right, standard deviation. That was that ugly formula up above, the square root of 1 minus p divided by p squared.
What?
That's on there.
They're going to Arizona.
P is 1/4. So 1 minus 1/4 divided by 1/4 squared.
It's either bowling or he wants to snowboard.
Oh, no.
Oh, what?
You're recording.
Uh-huh.
Where do you go to Arizona?
1 minus 1/4 is 0.75. And then I'm going to divide by 0.25 squared. And then square root. Why? Because that's the formula.
Bowling. Or he wants to.
Yeah, this is confusing. Crap.
It's just a formula.
So you're going to Phoenix.
You memorized a lot of weird formulas in geometry.
Yeah, but they used to be, but
Dude,
this
thinking
doesn't
about
have like a fun jingle behind it, and the
I don't know,
quadratic
we're talking about
equation.
It
That
did.
wasn't geometry.
Must be there, 'cause me and Dave used to be going.
Geometry, you had to memorize the volume of a sphere.
I don't know the volume of a sphere, so.
4/3 pi r cubed.
Oh, my bad.
That
You
is
know
your
what I
bad.
remember from- You know what I remember from geometry?
I don't know.
Proving that a triangle was a triangle. Because you can't use your eyes in math. You have to prove it with numbers.
That's why I don't teach geometry, because it's just...
I agree.
Go! Rubbing my legs.
Bro, I'm trying to stretch my legs.
All right,
I'm respecting your legs.
our standard deviation is 3.464.
Kiss me on my hot lip.
How do you interpret your standard deviation?
Spittle, you're going to?
No, I'm not. You're just not focused and paying attention.
Okay.
Thank you. Interpret standard deviation. Sorry, I just see Dia over there. She's saying it and she's got this attitude. On average, it's how far we vary from the mean. Yes, yes it is. Thank you, Dia.
Wow, it's a lot of squares.
Yeah. I don't get this. Like, so if I'm trying to find an average of something, this is what we pull out.
I was going to the other side because I just realized I can't.
I'm sure it's not too bad if you understand why you're doing
Do
it.
you do Mr. Change? Or can you talk about this in motifs? First off, I think. No, I know, but like for tomorrow.
504 thing.
What the heck, bro?
That's what I thought.
Is that?
Is there not? I thought we had to like.
Can't read,
every
bro.
day or something.
Tomorrow's all blocks.
I know. No, but we're
Oh,
talking
yeah,
about
it's
AP
dirty.
Lit.
Oh. All right. Now I'm going to teach you a calculator function.
Okay, I can do calculus.
Get your calculator out. What is the probability of selecting 5 candies to get our first cherry flavored one? No.
Oh, I know. How to set this up.
But that's kind of like, I don't know. I'm not even confident. You should just be grateful that I'm trying.
All right. So it's a geometric variable. So we're going to have geomet instead of binom. When it's exactly equal to a number, is that a PDF or a CDF? PDF. So we're going to do geomet PDF. Now, newer calculators are going to prompt you. It's going to ask for the probability of success and the X value you're interested in. If you have an older calculator, same things, just put the commas in between. So our probability of success is 1/4, and we're interested in X being 5, that it took 5 candies until we got that first cherry. Everybody okay if I put the calculator in the way?
Hold on. Yeah.
Alright, Geomet, yes I am charging my calculator. Geomet, PDF, same place as normal, CDF, binomes, EDF, all that jazz. This one definitely is easier if you go up instead of down. So the last two are Geomet, PDF, and CDF. We want PDF. And then my calculator asks for P, so 0.25, and X is 5. And I get 0.0791.
I didn't get that.
What did you get?
0.316.
Oh gosh, I'm so confused. Those people are trash. Like really tweakers that they try to fix.
Because you
Can we
multiply
wrap
by
this
the
up so I can
answer
go home?
squared.
How did I do that?
I don't know. Anybody else have calculator questions? No? Alright, probability of selecting at least 5 candies till we get the first cherry. At least 5. Is that greater than or equal to 5? Less than or equal to 5? Greater than. And what is the weird thing about the binome CDF that we had to do with the greater than questions? 1 minus. Same thing holds true for a geometric variable. So if I want to find greater than or equal to for binomial and geometric variables, I have to subtract from 1. And I also have to drop down 1 in my x value. So I went from 5 to 4. Now, if the question was, what's the probability I have to pick at most 5 candies? At most means less than or equal to. And if it's a less than or equal to question, you don't have to change the x. You use what's given. If it's a greater than or equal to, you have to subtract from 1 and change your x value by 1. So we're going to put 1 minus geomet CDF because it's an inequality. P is still 1/4 and our x is now 4. Everybody okay if I put the calculator in the way?
Yes.
Alright, so Geomet CDF. 0.25 for P, X is 4. And then I'm going to do 1 minus that, so I get 0.3164.
Wait, we do CDF, right?
CDF, yes, because it's an alligator.
You did 0.2. What'd you do for the
0.25, right?
What is our P?
Oh, 0.25.
Any questions?
Wait, what'd you put in for the x value?
4?
You got 0.6.
Just scroll up next
Yeah,
to
what?
it.
I got 0.68.
You need to put 4 in for X, Davis.
I know I did, and I didn't get that. Like,
Yes, I know. And then you have to subtract from 1. 1 minus your answer.
So now I do minus 1.
I thought there was. I don't know why I did. But like,
okay, roughly.
Oh,
yeah.
I'm sorry if you said this already, but how do you know which is CDF?
PDF is, so like number 5, where it's X
tell me a quick.
You know what I've noticed because I want to
equal
go.
means PDF. If it's
you're up.
at least, at most,
Hold on,
less
so
than,
your second
greater than, then it's a CDF.
So any
CDF, 0.25 and the value of 4, right? Data states.
All right, any other questions?
Look at my phone.
Oh, 0.4.
AB she kills hella trees.
And you thought I was bad.
Well, like, look at your freaking son. He threw away this in his trash can, and there's a paper right next to it.
I'm gonna have to yell at him.
I will if you won't.